So we're going to start our test review for linear equations, inequalities, and systems of equations. So we have this inequality, and we have to see which value of x is a solution. What I'm going to do is just solve this inequality for x. So I notice here that x is being divided by 4, so I'm going to get rid of that fraction by multiplying both sides by 4. So here that would be 4 times 2x, which is 8x, and then 4 times 6, I would add 24, and then that's greater than 4 times x divided by 4 makes x, plus 4 times 1 is 4. Now I have x's on each side of the inequality, so I'm going to move them to the left. So I'm going to subtract x from both sides. 8x minus x is 7x, plus 24 is greater than 4. So then I'm going to subtract 24 from both sides and get 7x is greater than 4 minus 24 is negative 20. Then I'm going to divide both sides by 7. And we would get x is greater than negative 20 divided by 7. So I'm going to simplify that to a decimal. And it's negative 2.857, approximately. So we just have to look at, well, which one of these is bigger than negative 2.857? And here would be our solution. Now, what we're going to do here is look at, well, how would we shade these solution regions? So what I'm going to do is take this inequality in standard form and solve it for y. So we have over here, I'm going to solve 3x minus 5y is less than or equal to 15 for y. So I'm going to subtract 3x from both sides. And you would have negative 5y is less than or equal to negative 3x plus 15. Then from there, divide everything by negative 5. Let me not write two negatives there. One thing to remember, when you divide by a negative, you have to reverse the inequality. So here we would have y is greater than or equal to 3 over 5 x. 15 divided by negative 5 is minus 3. So a few things with this plus 1 and negative 2/3. This less than sign means I have a dotted line. And I shade below. So if I'm just sketching which one this would be, it would start at plus 1, go down 2 over 3. We would have a dotted line here, and I would shade part of the graph below. Here, we would start at negative 3, so right here. I would go up 3 over 5, so roughly over here. It's a solid line. So here it's a solid line, and you would shade above because of the greater than sign.
Excuse an interruption.
So here you would shade above. Then if you notice, my area that is double shaded would be over here. So to graph, well, which one of those match that? It would be A. So now to graph this inequality, what I'm going to do is solve for y. So I'm going to subtract 5x from both sides of the inequality. And we would have 4y is less than, I would put the x first, so negative 5x, and that's a positive 20. So now I'm going to divide everything by 4. So we have y is less than negative 5 over 4x, and then plus 5. So I would start at 5 on the y-axis. And then my slope would say go down 5 and over 4. So down 1, 2, 3, 4, 5, over 1, 2, 3, 4. So we have 2 points. That's all I need for a line. However, if you notice, it is less than. So that would mean I connect with a dotted line because solutions cannot be on the dotted line because it has to be less than. So our solution region is going to be below the line. And then here, the less than means shade below. So my solution area for this just linear inequality would be right there. So now a hairstylist charges $22 for a haircut and $12 for an adult haircut. She wants to earn at least $1,000 and cut a maximum of 30 haircuts per week. The graph represents the constraints. So list 2 points in there. So I notice here I have a couple of possible answers. So I could have an answer that would be right here. And I have another answer that could be right there. Now, as I look at this is between 40 and 50 haircuts. So we have 2, 4, 6. So it looks like here we could do this solution right there would be 46 on the X haircut. So 46 adult haircuts. And we're going to need to switch this constraint to say a maximum of 50 haircuts is one possibility. Otherwise, you could have 46 adult haircuts here, and it looks like 2 child. So if you notice, those are less than 50 haircuts, so they make the first constraint. And then to show that they're more than $1,000, we could go 46 times 22, and we see that that's 1,012. And then here that would be 1,012 because we do the 46 times 22. And then we also add on the 2 kids, so plus 2 times 12. So this we make 1,036. So our points here that could represent them would be 46 on the x-axis and 0 on the y. And then we could also have 46 adults and 2 child haircuts. So here, a jewelry artist is selling necklace at an art fair for $180. The cost of materials is $650, and the artist is selling them for $15 each. So here with the inequality, 15 times n, again, that is how much you're selling them for, has to be greater than your cost, which is 180 plus 650 times n. So will you make a profit if you sell 15 necklaces? So again, what we would do there, again, this part right here, this 15 times n, is how much money that you're making in sales. And this part over here is how much the cost is. So if we plug in 15 there for n and look at both sides of the inequality. So if we say, what about 15 times 15? Is that greater than 180 plus 650 times 15? So we're just going to multiply those out and see. So 15 times 15 is $225 that you make. And then over here, 180 plus 650 times 15 gives us 277.50. So this is her income and this is her cost. So her cost is greater than her income, so this part is not true. So this is no, her income is $225 and her cost is $277.50. So now we're going to solve this to see where she would make a profit. So what we're going to do is get n on both sides. So I'm going to subtract 650 n on both sides. And we would get 8.5 n is greater than 180. Then we would divide both sides by 8.5. And we get n is greater than about 21.17. So this means she would have to sell more than 22 necklaces. Or more than 22 necklaces, or 22 or more. Now, we're asked also to solve systems of equations without graphing. That means we're either going to have to use substitution or elimination. Now, if I'm solving this system, you can do this in a few ways. One, you could use elimination, or two, you could use substitution. So what I'm going to do is use elimination. And I notice here, if I can eliminate y, this is 3y. If I made everything here -3. So what I'm going to do here is multiply everything by -3. So -3 times 5x would be positive 15x. -3 times y would be minus 3y. And then we need -3 times 13. And that would be -39. And then from there, you just line it up. So you have 15x minus 3y equals, and then you have -39. So then 15x minus 3y, or 15x minus 3x is 12x. -39 plus 3 is -36. Divide both sides by 12. And y would equal, that's -3. Now that we know y, we can use either equation to solve for x. So I'm going to use this original equation. And we have -5x plus y is really -3. So plus -3 equals 13. So to make that 0, I add 3 to both sides. So we have -5x equals 16. Then divide everything by -5. And we get x equals -3.2. Whoops, and I made a small mistake here. This was solved for x, so we have x equals -3. So in this equation, I can pick either, but I need to solve and plug in for x. So let me just erase this real quick. And I'm going to substitute this -3, but in for x. So here, I would go -5 times x is really -3 plus y equals 13. So then here you would have 15 plus y equals 13. Subtract 15 from both sides, and you would have y equals -2. So your answer here would be -3 for x and -2 for y. Now I'm going to solve this system as well. It is set up for elimination. If you notice, you have positive y and negative y. So we have -4x plus y equals 6. Add them, so that makes 0. So you have -9x equals 21 plus 6 is 27. Divide by -9, and you would have x equals -3. So if x equals -3, you just plug it into either of these. So -4 times -3 plus y is equal to 6. So we have 12 plus y equals 6. I'm going to subtract 12 from both sides, and we would get y is equal to -6. So our answer as an ordered pair here is -3 for x and -6 for y. And then our last problem here is an application. So Diego is making a large batch of pastries. She has 3 strawberries for every apple, and she uses 32 fruits altogether. So here, I'm going to say that the strawberries plus the apples is equal to 52. Now, she has 3 strawberries for every apple. So what that means is if I take 3 times the number of apples, it equals strawberries. That can be a little confusing because you see 3 strawberries and 1 apple. But in order to make them equal, you need to multiply the number of apples by 3, and it'll equal the number of strawberries. So if you look here, this system is set up to do substitution. So I notice here, instead of s, I can write 3a. So you could go 3a plus a is equal to 52. Or 3a plus a would give us 4a is 52. Then divide by 4, and you would get a equals. And now 52 divided by 4 would be 13. So we have the apples is 13. And now we have to get the number of strawberries. So down here, if I plug in the apples, 3 times 13 is equal to the strawberries. If I multiply that out, that means 39 here equals the strawberries. So we would have 13 apples and 39 strawberries.